And we're going to do a PQ1. So, let's go ahead and get started with that. How am I going to do that? New page. My advisor always said a blank page is a clear mind. That's what we want to do. Here is the thing I want to factor. So it is 2x. Wait, no, sorry. I hope this one works. 6x cubed plus 19x squared plus 2x minus 3. This is what we want to factor using the rational root, or sometimes they call it sometimes they call it the rational root method. Usually I call it the PQ method. Okay, so what does that entail? Well, the first thing we got to do is we got to go back to this theorem. Theorem 2, the rational roots theorem, which says if PQ is a root, then P divides the constant term and Q divides the leading coefficient. So what that does is it basically gives us some guesses as to what the roots are for this polynomial, which of course roots and factors are the same thing, so that'll give us the factors as well. So P over Q. P over Q is going to be things like, well, P is going to come from this 3, and Q is going to come from the 6. The first one I would always start off with is, okay, so what goes into 3? Well, 1 always goes into 3, whatever number that is. 1 always goes into Q, with, the 6. So I'd always start off with 1 over 1. That always works, doesn't matter what the numbers are of the polynomial. And then from there, the next one I might do is 3 also goes into 3, so I can do 3 over 1. But I need to do like all the possibilities for P and Q. So I need to do like, so 1's a possibility for P, and 2 is a possibility for Q because 2 goes into 6. We also have 1/3, 1/6. There's a lot of possibilities because 2, 3, and 6 are all possibilities for your Q. And we're still not done because we also could have 3 over 2, right? 3 is a possibility for P, 2 is a possibility for Q, so 3 over 2 is a possibility for the root. We could also get 3 over 3. However, notice 3 over 3 is the same as 1 over 1, so we can actually erase that one. We don't need that again. We also get 3 over 6, but we already have that. 3 over 6 is the same as 1 over 2. So I think this is all of our possibilities, except we also get the plus or minus of all of these. Okay, so these are all our possibilities. The next step is just to find one that works. We want one of these possibilities that works. The best way to do this is to use a graphing calculator, actually. Now, okay, so let me back up a little bit. So I know I said that you can't use more advanced calculators on the quiz and exams, but I think for this you can use a graphing calculator. And since you're at your computer anyway for this class, what I would recommend is to okay, so let me just start over. So we have this problem, this thing we want to factor, and the first step is to find possible rational roots. So things like 1/1, 3/1, 1/2, 1/3. And these numbers, the top of the numbers are coming from the p-value, and the bottom of the numbers are coming from the q-value. And just every combination that divides into those. So you get all sorts of combinations with plus or minus for all of them. And then you just have to try one and keep going until you find one that works. So I tried one and that did not work. Oftentimes one does work. A lot of times I'm nice to you and I'll give you one where one works. That's the nicest situation. But this one didn't work because it wasn't equal to 0. We wanted it to be equal to 0. But we got 24 instead. So what I do at this point is I would go to a graphing calculator and just keep trying these things until you find one that works. So like f of 3, well, that didn't work. F of -1, that didn't work. F of -3. Oh, there we go. We got one that works. So f of -3, so if you plug in -3, you get 0. So at this point, what I would do is I'd maybe make a little note and say, I tried a bunch of these. And got x equals -3 works. And once you have one that works, then you can move on to the next part of the problem. So we're not done yet. This was just the first part, but that's the first part. You find your rational roots, you find one that works. Okay. Let me if I can copy that easily. For the next slide. Okay. So now we know that -3 is one of these solutions that we're kind of looking for. And that also gives us a root, because remember, roots and solutions are the same thing. So now we know that x plus 3, you have to flip the sign. So x minus 3 is the root. X plus 3 is the factor. This is something you'll have to try to keep in your head straight. There's roots and factors. They're kind of the same thing, but they're just a little different. You have to flip the sign, for example, in this case. This is the factor. So this should go into this polynomial evenly. And now we're ready for the long division. So let's go ahead and, I'm going to kind of go through this kind of quickly, but let's do it. So x goes into 6x cubed, 6x squared times 6x squared times x is 6x cubed, 6x times 3 is 18x squared. So I'm going to draw a line, change my sign, and I just get x squared plus 2x. Okay, x goes into x squared. It goes in just once. It goes in x times x is x squared. X times 3 is 3x. I'm going to draw a line, change my sign, and I get -x minus 3. And I'm just about out of room, but I can see that this is going to work out beautifully because x goes into -x, -1 times, -1 times -1 times x is -x, -1 times 3 is -3. Now I'm really completely out of room, but if you draw a line, change the sign, you can see you're going to get a remainder of 0. So there you go. That's what you want. So if you're doing the PQ method correctly, you always get a remainder of 0. Now, if I give you just a random division problem, you might have a remainder. But if you're doing the PQ method and you do the long division, you always get a remainder of 0. Okay. So so we found the rational roots. We found -3 works. We did a long division with that, with the x plus 3. And this is pretty good. This is well on our way to factoring. Let me get a new page here. It's probably best. We just found this. But here's what we have. If this divided by this is equal to this, then we know this one times this one is going to give us that. And so basically, all I'm describing here is multiplication and division are inverses. So if division works one way, multiplication is going to work the other way. So we've actually successfully factored this x cubed plus 19x squared plus 2x minus 3. We successfully factored it as x plus 3, 6x squared plus x minus 1. That's the PQ method, basically. It allows you to factor just by kind of guessing. You guess, you find one that works, and then you do the long division. Okay. Now, if you're with me at this point, you're doing great. If you're lost, don't worry about it. This is just our first example. But we're actually not quite done yet because we can keep factoring. We also want to factor this. And that's not necessarily an easy factor. In fact, in this case, it's not easy. It's going to be one of these AC method ones. So I'm going to kind of go through that fast also, but just keep in mind, we're actually done with the PQ part of it. So we're done with the new stuff. So let's see. So now we want to factor. You almost think of this as a separate problem. Now we want to factor x squared, 6x squared plus x minus 1. If we're using the AC method, we want two numbers that, so a times c is going to be 6 times negative 1 is going to be -6. We want two numbers now that multiply to -6 and add to the middle term, which is, of course, if it's not there, you can always put a 1 there. So they're going to add to 1. And I can already see that 3 and 2 are probably a good possibility here. So if we make the 2 negative, maybe so if we make the 2 negative, that should work nicely. So when you're doing the AC method, the whole point of doing this is actually just to break up this b. This kind of breaks this problem up as 6x squared plus 3x minus 2x minus 1. So I just kind of broke up the b. It's not good when you break up with your boyfriend or girlfriend, but it is good when you break up the b because now we can factor this with grouping. So I'm going to pull out a 3x. I apologize, I'm going pretty fast here if this is new to you. Here there's actually like not a lot to pull out, but because it's negative, a -2, I'm going to pull out just a -1. I'm going to get 2x plus 1. And here, if you remember, here's where you kind of do the happy dance because those match. You pull out the 2x plus 1, and you're left with the 3x minus 1. Okay, so let's go back to the original problem. here's our original problem. I actually don't have room on this slide. Actually, let me just go here. Okay, yeah, sorry. Let me go back here. But okay, so our original problem was to factor this polynomial, this cubic, 6x cubed plus 19x squared plus 2x minus 3. And here's what we did. We factored it like this, x plus 3 times 6x squared plus x minus 1. And then we factored the 6x plus x minus 1 as 2x plus 1, 3x minus 1. So this gives a final factorization of x plus 3. That was our first factor, remember. We need that still. Plus these two that we just found. And that is your final answer. Okay, I am going to now stop.